So if we're going to do the volume of a sphere, let's go through some vocabulary terms like what is a sphere? Think about what your definition of a sphere would be. Maybe think about the definition of a circle. In fact, most people's definition of a circle is actually the definition of a sphere. Like the set of all points equidistant from a given point. A lot of times we think of that as a circle, but remember, for it to be a circle, it'd have to be the set of all points in a plane or in 2 dimensions equidistant from a given point. So we could specify here the set of all points in 3 dimensions or in space equidistant from a given point. How about the center of the sphere? Well, hopefully you recognize we kind of have already referred to the center, and that would be the set of all points equidistant from a given point. Well, that given point must be the center of the sphere. So maybe something like the given point from which all points on a sphere are equidistant. All right, how about the radius of a sphere? Again, be thinking, what's the definition of a radius of a circle? So how about the distance from the center of the sphere to any point on the sphere? And some people like to refer to the segment that joins the center to any point on the circle, or the length of any segment that joins the center to any point on the sphere. How about diameter of a sphere? Again, probably be thinking of your definition of a diameter on a circle. So maybe the distance between any 2 points on a sphere passing through the center, and that's the key, is that it has to pass through the center, or the length of the segment that connects any 2 points on the sphere that passes through the center. But the key is that it has to pass through the center to be a diameter. And last vocabulary term we want to go over is great circle. And the definition I have of a great circle is the circumference of the sphere at the sphere's widest part. You may be interested to know that great circles are used in air travel, that the shortest point between 2 places on a sphere will be the great circle that is along that path. And so that's why they use it for air travel, is that they want to go the shortest distance between those 2 cities or places. All right, now for the volume of a sphere. First, let's sketch a sphere. So first you sketch a circle, and then you kind of give it a belt. And we usually like to put the little dot in the center. And we can talk about its radius or diameter or other things like that. Now, the volume of a sphere comes from Archimedes, who I believe he took a cylinder that was flush, let's use a different color, right against the sides and against the top and bottom. So it touched at the bottom, it touched at the top, touched at the sides. And so we know a few things about the cylinder and the sphere. We know that their radii are equal. We know that the height of, well, let's go back and label the radius. So the radius of these 2 should be the same. And then the height of the cylinder should be equal to the diameter. It wasn't very straight. So the diameter. So the radii are equal, but the height equals the diameter, and that's kind of important. Now what he did is he took that, and this was a clay sphere, and he put it in, I don't know, probably glass cylinder, so he made it so that it was as perfectly as he could. Now he squashed it down. So what happens when he squashed it down is he looked at how high up that clay, once he molded it to the cylinder, how high up it was. So let's sketch that. And as far as history goes, and if you try this on your own, this would be a great, fun thing to do while you're cooped up at home, right? Is he found that the clay was right about here. And that amount was 2/3. So the volume of a sphere comes from how it relates to a cylinder that exactly fits it, touching it at all of the, right around the circumference, right around here, touching it at the top and bottom. So a cylinder, of course, is pi r squared h. I'm going to put V sub C for cylinder and V sub S for sphere. Now we know it's 2/3 pi r squared h, and this is where it comes back into play, is we don't have a height of a cylinder, but we do know that the diameter was equal to the height. But we don't want to stick diameter in there. We could for a second. Volume of a sphere is 2/3 pi r squared d. What we want to do is simplify that a little bit more, and we know that the diameter is equal to 2 times the radius. So the volume of a sphere is now 2/3 pi r squared times 2r. Well, if we use the commutative property of multiplication and multiply the fraction 2/3 by 2 and multiply r squared by r, we get our volume of a sphere, which is 4/3 pi r cubed. A relatively simple formula for the sphere. So let's use our newfound friend to do some calculations. So Earth's diameter is approximately 7,926 miles. By the way, if you want to stop the video and just look at this information and do it on your own and then skip to the answers and see if you got them right, that is a great way to do it. But our volume formula, I'm going to write it over and over again, 4/3 pi r cubed. Now right here we have the diameter, and since the diameter is 7,926, I got to take half of that to find the radius. So the radius, I'm going to write this out, and now I'm going to, in my calculator, I'm going to put it in this way. 4 times 3.14, they keep wanting us to use 3.14 times, and the radius is 3,963. And we're going to cube that, and then we're going to divide all that by 3. So as long as you know what to put where, really your calculator does all the work. I got 260,579,713,159.44 cubic miles. Did you? I hope you did. Now let's try a basketball. If we're given the circumference of 30 inches, what is the volume? First, we're going to have to use circumference formula to find what is the only number we need. If you notice in our formula, 4/3 is a constant, pi is a constant. The only thing that we don't know is the volume, and it's because we don't know the radius. Or if we do know the radius, we can find the volume. Or if we know the volume, we can find the radius. Those are the only two variables we have. So with circumference, we can get radius, and that's what we need to do. So since circumference equals 2 pi r, circumference equals 6.28 r, and this circumference is 30. So I should have just stuck 30 in there to begin with. And then divide both sides by 6.28. Now, of course, what I did was, in my mind, I did 3.14 times 2. So I get 4.7770700 ... and that's going to be inches is the radius. So now for the volume, I want to keep that whole number that's in my calculator right now, because I don't want to round into my final answer. I mean, I'm already using an estimated amount right here with 3.14, so I don't want to mess with that any more than I have to. So right into my volume formula equals 4 times 3.14 times that 4.777 ... and I'm going to leave it, like I said, as much as I can in my calculator. I'm just going to hit raised to the 3rd power in my calculator, and then divide that by 3. And I got 456.4 407,967 dot dot dot. So I'm gonna go with approximately 456.4 cubic inches. All right, and now for the baseball. Now this time they gave us volume and asked us for the radius and the circumference. Well, in order to find circumference, we have to find radius anyway, right? Well, again, we use our formula. Volume equals 4/3 pi r cubed. But this time I replace volume with 12.77, and that equals 4 times 3.14. I don't know the radius, so I'm going to leave that cubed over 3. So the first thing I can undo is multiply both sides by 3 to get rid of the division by 3. So 38.31 equals 12.56. We might as well memorize 4 times 3.14 since we're going to be using it a lot. R cubed. So now to get the radius, I divide both sides by, make that decimal a little bit bigger, 12.56 on both sides. And I get a nice long decimal, 3.050159. I'm going to put dot 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 equals r cubed. So now what I have to do is I have to cube root. So the way we cube root is you've got to have it in your calculator and choose the root of 3. Now if you're tempted to say, oh, that's just 1, well, remember, we're not dividing by 3. 1 cubed is still 1, so it's got to be more than 1. But 2 cubed is 8, so I know it's between 1 and 2. And I get approximately 1.45 inches. Now that's approximately the radius. Now if I really want to find circumference, we remember that circumference is 2 pi r, so 2 times 3.14 times this 1.45. But again, I'm not going to use that rounded number until my final answer, and then I'll round my final answer. So leaving that whole long number in my calculator, multiplying it by 2 and 3.14, I get 9.1075279. So if I round it to the nearest hundredth, I get 9.11 inches, because circumference is one-dimensional. So you can see that you can manipulate that formula in many different ways.